end of 152, we do relativity to first get you to start questioning what time means, and then get into quantum where you start questioning reality.
Yeah, I love the double slit experiment.
Oh, yeah. And also the fact that I could just spontaneously show up in the bathroom right now. It's a non-zero probability.
If all of your atoms decided to tunnel.
Yes,
Yeah,
absolutely.
You're taking into account every possibility, no matter how bizarre it is.
And if you've read some Douglas Adams, the infinite probability machine sort of plays on that. And if you don't know what I'm talking about there, you should read Hitchhiker's Guide to the Galaxy. Or listen to the radio.
The movie's alright.
Pardon?
The movie's alright.
No.
The BBC TV
See,
show.
There's certain things that you can do in this class and say, you can talk about Star Trek, any of the TV series with great reference, I'm fine with that. You can badmouth the J.J. Abrams versions that he bastardized. I'm okay with that. You can talk with glowing words about Hitchhiker's Guide to the Galaxy, either the books or the radio series, or even the original TV series, but do not ever say that the movie was anything beyond horrible.
Yeah, I think
It was entertaining.
I think anybody that says anything about like the movie being better than a book is like lying,
right.
or they're just referring to Stephen King novels and movies because they seem to turn out okay.
But not
Well,
bad.
he's a mediocre writer. The stories I find Stephen King stories are really entertaining,
Yeah,
but his writing style is,
it's lengthy.
Well, when you don't take any notes the entire time you write, you just write it all at once.
oh,
That happens.
and you know, one novel a month would eventually have something to do with it. That's a great segue back to physics, from horror to physics. All right, so right now, my position. This is the positive, negative, zero thing.
It's positive.
My displacement,
Also positive.
Positive.
my position,
Negative.
displacement,
Positive.
position,
Negative.
Negative.
displacement.
Also
Negative.
I heard somebody say something off.
She said also.
I said also negative.
Oh, okay. My displacement?
Negative.
Zero.
Oh, I'm sorry, zero.
Yeah, let's not do the parallax thing where, you know, people from different angles see me on one side or the other. If I'm hovering around there, I'm at zero.
Zero, yeah.
All right. Now at this point, there is a scalar analogy to displacement. A word that when you see, you should immediately think scalar. And that is the word distance. Distance is a scalar term. You see the word distance, it's not a matter of, do you care about direction? No, I can't care about direction because distance doesn't have a direction. And the symbol for it is just, well, that symbol except without the vector symbol, delta x, delta y, delta z, so. So I was born in Florida.
Really, what part?
Just outside Boca Raton, Boynton Beach.
Get out of here.
There was no hospital in Boca Raton at the time, so Boynton Beach was the nearest one.
I lived in Delray Beach for quite some time.
Oh, were you the guy, you owe me?
Maybe I shouldn't have said.
I was in Florida for 4 months and then they moved.
Oh, okay. Yeah, I lived there
They took
for-
me with them for some reason.
All told, I lived down there about 20 years.
Ah.
Lived there a couple of different times.
So you're more Florida man than I am. All right, so I'm born here in Florida. I've moved basically up and down the southern east coast. And then down there. So let's just assume that I went from birthplace to Richmond and then back. And I'm gonna make up a number, let's say it's 500 miles. I don't know what it actually is, but we'll say 500 miles. When I get back home, what is the distance I have traveled?
1,000 miles.
What is my displacement?
Zero.
500 or zero. Sorry.
I haven't gone anywhere.
You say.
So distance cares about the actual path traveled, displacement just cares about where are you relative to where you started. It doesn't care about all that stuff and piddly stuff in between. So delta x equals 1,000 miles. Delta x with a vector symbol over it is equal to 0 miles. Next level, velocity.
I really thought you said philosophy, and I was about to get very excited about where this is going. But I'm still excited, it's just a different type of excitement. A different excitement.
Velocity. The symbol for velocity is a V with a vector symbol over it. Clever the way they did that. Velocity and vector also start with the same letter. I know that's not a shock, but I'm just pointing that out because the scalar analog is speed. And speed and scalar start with the same letter. But the symbol for speed is V
Yeah.
without a vector symbol. Now, velocity is the rate at which position changes. Mathematically, when you say rate, it's implied, although for the purist, we probably have to throw in a few more words, but generally when you say the rate at which something changes, it's talking about with respect to time. And so velocity is also the change in position over the change in time. So now we have to get into a distinction between two types of velocity and what's meant when I just say velocity. There's instantaneous and then there's average. Only problem, if I ask for the velocity, what is the velocity? By default, it is the instantaneous one. If I want the average velocity, I need to specify average velocity. Displacement, there's also instantaneous displacement. And then overall. By default, it's the overall displacement. So I say what's, after the car is gone, you know, in this, when I got up to Richmond, what was my displacement? I don't need to I don't need the extra adjective in there to narrow it down. If I ask for the displacement, I'm talking the overall. If I want the instantaneous displacement, then I need to say instantaneous.
Can you explain the difference between instantaneous and average velocity? Like,
Yes.
Okay.
All right, here we go. By the way, most of you don't know this, but I am as fast as Usain Bolt, and I'm about to show you why.
Awesome.
Actually, I'm faster than Usain Bolt.
Are you faster than Sonic the Hedgehog?
Using the same logic that I'm about to use, yes.
What about the speed of light?
Speed of sound.
We're about to find out.
Light's a little bit different.
I was
because
about to
it's
say,
harder
that's
to
pretty
bend.
fast.
All right, so Usain Bolt and I are about to race around a track. We go around, Usain Bolt goes around in, let's say, 44 seconds. I go around in 200 seconds.
Is this like a 400-meter, like quarter of a mile?
Standard track.
Yeah.
Now, most of you look at that and go, well, he's obviously faster. But let's take a look at our average velocities. Average velocity is the change in position over change in time.
Oh boy.
Uh-oh.
So, when he finishes, what is his change in position?
Zero.
Zero.
So his average velocity is 0 meters per second. When I finish, what is my average velocity?
Zero.
200.
Just as fast as Usain Bolt. Now, when he finishes, I'm somewhere over here.
Oh my gosh.
So, in 44 seconds, he has gone nowhere. In 44 seconds, I have gone somewhere. I have a higher average velocity, higher magnitude of average velocity than he does. I'm faster than Usain Bolt.
So what would be instantaneous velocity?
All right, so instantaneous, we're not dealing with the overall displacement like here. Instantaneous, we're dealing with where you were just a moment ago, whatever a moment is. In calculus, it would be an infinitesimally small bit of time beforehand. So we start out, when he's here, instantaneous, you're looking at what is this displacement in that small little segment in however much time it took. Whereas in the same amount of time, I have a smaller instantaneous displacement. Instantaneous is dealing with, I think I said it before, it's that moment before you're sort of keeping track of time.
And you said instantaneous is the default.
When I ask for the velocity, yes, instantaneous is default.
Okay.
Unless you specify.
Correct, correct. Oiza?
Yeah, I'm kind of having trouble with the symbol. So you said that average velocity is the change in the position over change in time, but then you use the symbol for displacement when you were talking.
But remember that displacement is also change in position.
Okay.
And Harrison?
That was my exact question.
Okay.
So, yeah.
And let's say question.
Now, just to add really a joy to your life, some textbooks will actually use these words interchangeably.
Oh, okay. That's nice.
Yeah, and here's the thinking behind it. I said before, you get to choose the origin wherever you want it to be. So if I made the origin and my starting point the exact same thing, then my displacement is my final position minus my initial position. If my starting point is the origin, that's just 0, and now I have a position and displacement that have the same value. We will, for convenience, for a lot of what we do, we will do the same thing. We will make the origin the starting point, or the starting point the origin. However, they are officially not the same thing, and so that's what we're sort of going over right now. Now, in terms of plus minus 0, since velocity is instantaneous, the word velocity is implied, I'm talking about the default of instantaneous velocity. It's where am I, try that again. My velocity, therefore, would have the exact same direction as my instantaneous displacement. So if I go from here to here, I just moved in the positive direction. I went from a larger negative number to a less negative number based upon the origin. And therefore, my velocity was positive just then. My instantaneous velocity was positive. So if I'm moving in the positive direction, my velocity is positive, instantaneous, understood. And now my velocity is negative. All right. Yes, Brian.
Is there an equation for instantaneous velocity, or is it the same as the equation over here?
Who in here has had calculus?
I'm taking calculus.
Not pre-calculus.
I took it like over the summer. but-
Okay. Instantaneous velocity, the limit as delta t goes to 0 of the change in position or change in time. So basically you let the instantaneous velocity would be, it's still change in position over change in time, but you're letting that change in time become infinitesimally small, And for those who've had calculus, dx dt.
Aw, I remember that.
I don't.
All right, this is beyond the scope of the course, so for those who don't, who look at this and go, what did the D's mean? Don't worry about it.
Oh, I don't know what the D's mean, I just remember seeing them.
Okay, the D's just stand for derivative.
Okay.
If it does, it's basically, you take the delta and you make it incredibly tiny.
I don't miss it. I don't miss it.
Ah.
Me neither.
So to clarify, are we responsible for the first equation that you wrote above the derivative bit?
That,
Yes.
not really, only in that you understand the concept of what instantaneous velocity is. All right, so here we go. My position,
Positive.
displacement,
Positive.
not hearing the chorus of it. Maybe everyone's speaking so simultaneously, it sounds like a single voice or three voices. Maybe that's it.
That's exactly it. We're just like in sync like that.
Wow, that's so good. And it's like the river dance of classes. All right. My velocity,
Positive. Zero.
I heard somebody just say it.
Oh, 0.
Zero, I'm not moving.
Check.
Yeah, my arms are moving, but.
Put on the earth. The earth's moving.
Like what?
We're assuming that the center of my mass is close enough to not moving. It's similar to if I'm standing here, this is position is equal to 0, even if it looks different from Isaac and Ray's point of view. All right, my velocity,
I don't know, like
Negative.
1 mile an hour?
no, I'm looking for positive, negative.
Oh,
zero.
negative.
Negative.
Okay, let's try that again.
Positive.
Yes. My velocity,
Negative.
my, position,
Now negative.
Negative.
and my displacement.
Negative.
My velocity,
Positive.
displacement,
Zero.
yeah, that was,
Oh my God.
I was looking for a quicker response on that one. All right, and position,
Negative.
Negative.
velocity.
Positive. Are you like moonwalking?
No. I'm trying to move slowly. I'm still, oh yeah, it is positive, I'm sorry. That was my bad.
I think you're moving the wrong way. You're moving this way, so you're going negative, facing forward, but
Right.
backwards is positive.
Actually, I wasn't moving at all, the rest of you were moving.
Oh, that's true, my bad.
Wait, so, I'm kind of, so when is this displacement gonna be a negative value?
When you're on the negative side of where you started.
So if you, okay.
So if this is really my starting point, then this is all negative displacement over here,
Okay.
and then all positive displacement over there. Olivia?
This is a weird question, but, how do they calculate, like speed within like, I don't know, like superheroes, like Superman or whatever? I don't know.
I mean, there's, let me talk about radar guns and actually speed traps. I think it will relate. So for the most part, you are ticketed for average speed. You're not ticketed for velocity. I don't think there's, at least you don't get a speeding, there's not a velocity ticket. The person was going 10 meters per second east. No, you were going whatever the actual value was. So I'm like wondering, is 10 meters per second speeding anywhere? Probably. Anyway. So for the most part, radar gun, they hit your car with radiation. That radiation comes back, and there's a slight shift in the radiation that's being sent out and received. And that difference in the frequency of the light that hits your car and comes back is indicative of the speed that you're going.
They're giving me
So-
cancer?
There actually, if you look at some of the early radar stuff, there was some of the police officers, the company who made the radar guns, said they're absolutely safe. But there's a policeman who constantly kept the radar gun on and kept it right there between his legs, and he had this massive tumor on his leg. So, yeah, prolonged exposure, not good.
Real smart.
But, I wouldn't stand in front of it for a long period of
Yeah.
time, but no, I think you're safe. You're probably more in danger from radiation from
From
our
the
sun.
sun, yeah.
Now, But not everywhere checks instantaneous speed. In the case of speed checked by aircraft, especially in rural parts, basically they have these there's two marks that they have, two landmarks,
Right.
and they're timing how long it takes you to get from one place to the other. And then, and basically they're timing you. And so that's finding average. So if you want to bring in superhero physics, how fast they're going, some of it, well, probably depends on which issue you're reading, but Superman jumped across the Atlantic and was in Europe 2 seconds later. Well, you now know the distance. They give you time, and then you can calculate average speed at least.
Maybe the rotation of the Earth, perhaps.
In 2 seconds, rotation of the Earth probably not significant, but
All
depends on
right,
how precise you want to get.
I just wanna make sure, are you saying that when police officers clock you, they take the average of your speed over a certain time? Or are you saying that they just take your speed and it's already averaged as they're hitting you? Because,
Radar gun is pretty instantaneous.
okay, if I were to go like 45 and like a 35, and obviously that would be over, but if I were to slow down to like 40 within a second or two, which would, I mean,
If
it's kinda
speed checked by
fast.
aircraft, you're probably good by, if you want to speed in one section and go way below in the other section, as long as whatever those landmarks are. I'm assuming they know, and I've never heard anybody say, yeah, it's between this stop sign and that stop sign, that's what they're planning.
Well, there's a spot on the street that I drive every day to work that they just sit, cause it goes from 50 to 45 to 35 in like the span of, I don't know, a half a mile. And it really is a speed trap. They only did that because it's like slowing down into a roundabout. So I was just
Okay.
curious.
Yeah, I just assume they're using radar guns.
Yeah, they are.
Or you could go in there and say, I understand how these things work. That is not an accurate result. And you launch into the physics of it.
Yeah.
And then you get the judge who's had physics and understands it, and they'll laugh at you, but.
Yeah.
Rumor was one of the professors at USC, one of the physics professors at USC pulled that stunt and got away with it. Don't know if it's true or not, but